So in this question here, we've got a pulley situation where we've got a weight of mass x kilograms at point A here being pulled along by a light inextensible string by a pulley system, and hanging off the edge of, let's call this a table, the pulley system here, we've got weight B, which is 2x kilograms. So this weight is twice as much as this weight. We can see that from 2x to x. And the acceleration of this system has been calculated at 4 times the force of gravity divided by 9. And we want to express the forces in the vertical and horizontal direction. Then we're going to express the tension, and then we're going to calculate the coefficient of friction mu. Because the one thing that is happening on this table here, there's a little bit of friction coming off the table as A slides across. So how are we going to represent that? So part 1, let's go for part 1. Express the forces in the vertical and horizontal direction. So first of all, let's go with the vertical one first. So the system is travelling in this direction. So what we've got, we'll have the mass of this block hanging down going against the tension in the string. The tension in the string is going in the opposite direction to the direction of travel. So what we'd have is 2x g. So that's our block, its force going downwards in the direction, and then minus t. And then what we do is we set that to mass times acceleration. So mass is 2x and acceleration is 4 9 g. Well, I'm just going to put a there for the moment. Now what this uses is the principle of Newton's law of motion, force equals mass times acceleration. So we've got the forces on this side and mass times acceleration on this side. So that's what we've got on our vertical direction. So then now I'm going to put the A in there. So we've got that as much as we can for now. So 2xg minus t equals 2x times 4g over 9. So that would be 8xg over 9. So that takes care of that. Okay, now let's express the forces in the horizontal direction. So let's have a look at this one. So this time the system is going in this direction. So that's the direction of travel. So now tension is going in the correct direction. So here we're going in the downward direction. Now we're going in the horizontal. So tension is going in the right direction. Minus, we got xg for this block A, so minus xg, and then we need to multiply that by the coefficient of friction, T minus mu xg, and then that equals mass times acceleration. So that would be the mass of the block, which is x, and then acceleration. And then now I'm going to put the acceleration in. The acceleration is 4g over 9. So we've got T minus mu xg equals 4xg over 9. Just put an x into there. Okay, so with that we can now try and put or isolate our tension. Now this one here looks like the easiest one to do it with, because here we've still got our coefficient mu to contend with. So I'm going to use this one in the horizontal, in the vertical direction. So tension, so part 2. So we've got 2xg minus t equals 8xg over 9. Let's bring the t over here and the 8xg over 9 over here. So then I've got t here, and then I've got 2xg minus 8xg over 9. So this would then be 18xg over 9. So that'd be the equivalent of that. So if I change that to 18xg over 9, I've now got a common denominator, and I can just do 18xg minus 8xg equals tension. So therefore that will give us, our tension will be 18 minus 8, which is 10xg over 9. Okay, so that's the tension. Now, last bit, we want to try and calculate our coefficient of friction. So let's do part 3 over here. Let's keep those all separate. That's number 1. Okay, So part 3. So we can use one of our resolving forces here. This is the one with the mu in it, so that's obviously the one we want. We've got T minus mu xg equals 4xg over 9. So that's from our forces resolved in the horizontal direction. Now we now know what T is. We've calculated that as 10xg over 9. So then we've got 10xg over 9 minus mu xg equals 4xg over 9. So now it would be a good idea to get everything divided by 9. So if I put a divide by 9 here, I can stick a 9 in there, that's fine. So now everything is all divided by 9. So now I can just write 10xg minus 9 mu xg equals 4xg. Okay, now I've got an xg in all of my terms here. So what I would do is divide by 9, divide by xg, and we can get the mu along with some different numbers. So now we've got 10 minus 9 mu equals 4. So now we get mu out of that. So if I bring 9 mu over this side and the 4 over this side, so let's go over here. So now I've got 10 minus 4 equals 9 mu. Well, 10 minus 4 is 6. So divide by sides by 9. So 6 over 9 equals mu. So therefore mu is 2/3 or 0.666. Okay, so that then gives us our coefficient of friction taken care of here. So I'm happy with that as my result. I've got my tension here. So tension is 10xg over 9. And I've got my forces resolved for the horizontal and the vertical directions. Okay.